Hey guys, welcome to week 14. Can you please give me a smiley face if you are at home and you can hear me okay? Awesome. Welcome to Friday. We've almost made it to the weekend. We are still working in Unit 4 this week. We're doing a couple different sections, tangents to circles, and then inscribed angles and arcs. So this will be next week, like Monday, Tuesday-ish, and then this was, I think, Wednesday, Thursday of this week. So that way you're kind of covering everything that you needed to learn this week and the beginning of next week. So here's your week 14 essential question. Please take a moment and copy it down. I want you to write down my whole blue sentence, and by the end of today you'll be able to fill in the 2 blanks. So our essential question says a tangent line is blank to the blank of a circle. So inside the drop box, you will write that whole entire sentence and you will fill in the 2 blanks for me so that it is a completed sentence. Check mark if you're at home and ready to go. Green check mark, please. And it will be back up again at the end. So first we're going to focus on tangents to circles. And the big idea is understanding your vocabulary words. So we're going to understand the word tangent. Isaac, it will be up again at the very end. So on this slide in your notes, Cody, there's some notes right there on the corner. We are going to point to a couple things, highlight a couple things. So even though you guys have the pre-printed notes in front of you, I still want you writing on them, interacting with them, all of that good stuff. So I know it says drag, but it's already kind of on the picture for us. So these are labeled tangent. I'm grabbing my pointer finger. These are labeled tangent, secant, and chord. So just like we did last week, remember how I showed you the picture and I asked you to write a quick definition? I'd like you to do the same thing this week. So let me give you about 30 seconds. Based on what you see, how would you describe secant, chord, and tangent? So let's take about 30 seconds or so and write a quick definition on your notes paper. So let's see how we did. Let's start with chord. Anyone in the room want to volunteer? What would you say a chord is, just based on this picture? Are we shy on a Friday? I don't like to draw names. I don't want to draw names. So looking at the picture, let's do it this way. How is a chord different than a secant? A secant does what? Goes through the circle. It's a line. It continues. It goes on and on and on. So secant is a line that passes through the circle. How is chord different? Chord does what? It stops. Yep, exactly. It stops. It's going to have 2 endpoints. So that's the main difference. Everybody okay with that idea? Chord stops at the 2 endpoints of the circle. The secant is a line that would continue through the circle. What about a tangent line? A tangent line does what? What do you think, Sabella?
Goes through one. It connects the circle at one place and goes through it.
Good. So it's going to touch the circle in one spot only. So it kind of doesn't go through the circle, because if it went through the circle, we could say it has 2, right? So a tangent line doesn't go through the circle. It touches the circle, and that's it. It touches in one spot. So make sure you have something like that written down for each of those. So a tangent line touches in one spot. A secant line goes all the way through my circle, and a chord has 2 endpoints. We're going to learn something else that's super special about tangent lines today. Tangent lines hit at a very specific spot, and they form a very specific kind of angle. We're going to see that on the next slide. So here's our tangent theorem. A line that is tangent to a circle is, I'd like you to underline these 2 words in your notes. Ready? Perpendicular to the radius of the circle. So what is very special about a tangent line? It's perpendicular to the radius. So look at my picture. Here's a radius. Here's a tangent line. I automatically know that it's going to be a 90 degree. every time. So if they don't draw in a 90, I get to draw that in myself. How do I know it's a 90? Because they are telling me it is a tangent line. If you have a tangent line, automatically perpendicular. That's some key pieces of information for us. So we're going to put this to some use, do some problems with some numbers in it. But does anybody have a question so far? Did we highlight those two words in the theorem, perpendicular, radius? Can you write them down then if it's too small in the notes? Sorry. I just figured you don't want to have 15 pages of notes. So I try and make it, put them on one slide for you guys. Okay, example 1, here we go. So in your picture, we're going to add all of this information to our picture. It says if line AD is a tangent to a circle B at point C, and you're already thinking, oh, my eyes are glazing over, I don't know what that's saying. We need to take every little piece of the puzzle and write in what we know. So let's look at this again. If line AD, so look at this with me. So here's line AD, and the line keeps going forever and ever and ever. So they're saying this line right here that my finger's on is tangent to the circle B. Anytime we name a circle, they use the center of the circle to name it. That's why they picked out B. At point C. So it's tangent at point C. What does that mean about this line and about BC? What can I add to my picture because they said it was a tangent? A little square in the corner. Perfect. Let's add that in. That means it's 90. So when I say the word tangent, what does tangent mean? It's going to make a 90 degree with the radius. I haven't answered my question yet, but I'm just helping you pick out key pieces of information. Now it says M angle ABC. What does M mean? What do you guys think it means when it says M? Like this. Perfect. It means measure. So the measure of angle ABC. So let's see, where are they talking about? A, B, C. A, B, C is 48. So where am I going to put the 48? Next to what letter? Next to B. So make sure you guys are understanding that. Whenever we're talking about a measure, they use 3 points, but they're always talking about the point that's in the middle. That's how we label our angle. So this angle is 48 degrees. Let's put a 48 in there. Let's check out my question. What is the measure of BCA? Okay, follow my finger. They want to know the measure of BCA. BCA. So really, what angle are they asking for? What letter? C, because it's in the middle. How much do we know C is? 90. It's not a trick question, you guys, I promise. And these are taken straight from your quiz. So what's the measure of BCA? 90. How did I know it was 90? Because what word did they use? Tangent. Yep. So sometimes they're just checking. Do you know your vocabulary? Do you know that tangent means 90? We did no math just now. Did you realize that? Nothing. We just looked at our picture. You have a question just like this on the quiz. So I think we're doing 5 examples today. You guys have 5 quiz questions. What I did is I just changed some of the numbers. That's it. So if you can do the 5 with me today, you're going to do great on the next couple quizzes. Any questions before we move forward? We okay so far? Okay, let's try this one. Same picture, but I'm changing up your numbers again. So if line AD is tangent to a circle B, so what's the very first thing I need to add to my picture? What does tangent mean? 90. Please draw in your 90. And measure of angle ABC is 42. So here we go. ABC. ABC is 42. Let's put our 42 in there. So far so good. What's the measure of BAC? So which one are they asking me for? BAC. They're asking me for up here, for that little corner A. I'm going to put an X in there. That's the one I don't know. When we know 2 angles in a triangle, don't we know the third? Yes, should be the answer. All of our angles in a triangle always add to be what? 180 is a total triangle. So let's add up what we know. So far I have a 90 and I have a 42. So far I have 132 degrees. How am I going to find the one I don't know? 180 minus 132. Okay, so how many degrees is my missing one? Good job, Bryce. Anybody else? Not 68.
48.
Good job. Neil got it. 48. Anthony got it. Great job. So 48 degrees. So what are we going to have to keep in mind this unit? Number one, what does tangent mean? Forms a 90 degree with the radius. And secondly, how many degrees does the circle equal? 180. Everybody okay? Question 2 on the quiz right here. Okay, question number 3. Same picture, I'm asking you a different question now. It says if line AD is tangent to circle B at point C. Okay, so this line's our tangent line. Here's my radius. So what can I add in? 90 degree. Are we seeing a pattern here? There's a pattern to tangent lines. It says measure of ABC is 42. So let's put that in. ABC. This time this one is a 42. What angle is it asking me for this time? Different question. Yes, but what part of A? So we got to make sure, you're right, they want A, but A kind of has 2 spots, wouldn't you agree? A has like this little angle, and then A has the big angle. That's the other reason they're always going to do 3 letters. So they're talking B, A, D. They're talking that outside fat angle. Everybody okay with that idea? I want this outside fat angle out here. I'm going to call that X. Yikes, how do I find that one? Ooh, good answer, good vocabulary. Okay, so we're going to use our supplementary angles theorem. But first, I need to figure out what's my missing angle. So let's do this inside angle first. Because if I know the inside angle, let me draw this line in. Maybe highlight this on your paper with like a bold pencil line or something. Because these 2 angles are going to add to be 180. Kind of disappeared there. Let me grab a different color. These 2 angles together, A and A, outside of A, inside of A, are going to add to be 180. So let's start with the inside of A first. So the inside of A would be 90 plus the 42. We just did this one, right? So 180 minus the 132 gave us 48. So this top one is 48. How do I find X? Adrian gave it to us a minute ago. Adrian said the outside of A and the inside of A are supplementary, and supplementary angles add to be 180. So I could do 180 minus the 48, and I would get 132. So X is 132. I have a lot of stuff going on there. Let me just erase some of these things. So this one is 132 because they were on a straight line together. Straight lines add to be 180. That one was 48. Okay, so 3 types of questions so far. The first question asked you, what's this angle going to be? We knew that was 90. The second time I asked you to solve this one. Third time I asked you to solve this one. Fourth time I asked you to solve that one. So same picture each time, 4 different possible quiz questions. So just make sure you review those before you take your quiz. Let's try another one. This is a different kind of question. Do not go and draw your 90 in. You're going to see why in a second. Let's see what it gives us. It says the measure of ACB is 32. Can you guys all draw 32 on your paper, please? ACB is 32. So that's right in there. And the measure of CAB is 38. CAB, 38. Look what the question's asking. Is the line tangent to the circle? They're not telling me it's tangent. They're asking us, is it tangent, yes or no? what does this angle have to be for it to be tangent? It would have to be 90. So the question is this 90, yes or no? And we got to figure that out. So is this 90, yes or no? And that will answer my question. So if I know two angles of my triangle, can you guys please solve for that third one? Let's solve for it. Let's see. Is it 90? Is it not 90? What is it going to end up being? Okay, and I put a little note on here that I'd like you guys to add to your notes. It says x must be 90 to be a tangent line. Right? They have to meet at a 90 degree in order to call it a tangent line. So we are trying to figure out, is it 90 or is it not 90? So far I have 32 plus 38. So how much am I at so far? 32 and 38 make 70, thank you. So if I do 180 minus 70, I get 110. So x is really 110. Is that 90? No. So do they meet at a perfect 90 degree? Is it a line of tangency? No. So is line BC tangent to A? No. And if it asks you to explain why, we say it's not 90 degrees because your homework asks you for justification. So that's all you need to say. So no, because it was not 90 degrees. Does anybody have a question on this one before we move forward? Again, another quick question. I just changed the numbers on you. Okay, next picture. So now we're getting into kind of like a double triangle going on up there. Don't let it scare you. It's the same kind of problem that it was before. This one says if angle DAB is 35, so let's write that in. DAB, I'd like you to put the 35 on your paper. Okay, so that's a 35. If radius BE is a perpendicular bisector, okay, so perpendicular is helpful, bisector is helpful, of chord AC, then what is the measure of ABC? So which one do they want me to find? Let me highlight it. A, B, C. So they really want to know this big fat angle right here. That's what they're asking me for is B. Does everybody understand what they're asking us for? Not how to get there, but do we understand the question? So let's kind of dissect these vocabulary words. What information are they giving us? What does perpendicular mean? 90 degrees. What does bisector mean? Cuts it in half. Cuts it in half. That's huge. If you don't know your vocabulary, we're not going to be able to finish solving the problem. So let's add in what we know. Perpendicular means it crosses at a 90. That's super cool. We can draw in our little boxes. And what we learned previously in the year is that if this is a bisector, meaning it cuts it in half, that means the left side of the triangle and the right side of the triangle are going to be the same. So if this is 35, what do you think that makes this corner?
35.
35. Good job. All because they told us that word, bisector. You know two of the three angles. You can find the third one. So let me highlight the big triangle for you that I'm talking about, that I'm looking at. And if you have your homework, I realize that for the tests and quizzes, it's on a computer. If you right-click and you hit print, it will print out your tests for you. Because I like to write on things. I'm like a paper pencil kind of a girl, so I like to highlight things, write on it, and it's hard on a computer screen. So I would recommend right-click, print, and then you can do all the same stuff we're doing together. So here's my monster triangle. Everybody okay with me drawing my monster yellow triangle? So this corner is 35, this corner is 35. They want to know this corner. What do we know about the three angles of the triangle? They're going to add to be 180. I feel like a broken record today, right? So let's try. So far I have 35 and 35. So how many degrees do I have so far? 35 and 35? I feel like you were all at home and not here with me in the room. 70. Awesome. 70. Okay, so then how am I going to find my missing angle? 180 minus the 70. I get 110. So my missing angle is 110. Practice makes perfect. Did you know that your homework looks just like these? Some of you are nodding because you do your homework every single unit. They do. The homework and the quiz are the same. Shocking. I know, shocking. So the students that do their homework do amazingly well on their quizzes because it's the same. Sometimes K-12 even uses the same number. They don't even change the number. It's the same exact question. You know what they're testing? To see who does their homework and who does not do their homework. Not rocket science. It's just who's going to put in the work. So practice makes perfect with math. It's not like history. But don't tell Mr. Bremer I said that. History you can sort of just scrape by, right? Like read it real fast and like take a quiz and still get a great grade. That's what I used to do. Math's not like that. Math you just got to put in the effort and practice. Okay, one more and then we'll do our last little section today. It says if radius BE is a perpendicular bisector. We just said those words were important, so I'm going to highlight them, underline them. Perpendicular bisector of chord AC, then what is AB to the nearest tenth? So here's what they want to know. They want to know this length this time. How am I going to find that? Well, if this is a perpendicular bisector, didn't we just say that that means the two parts of my triangle are the same, right? So if my height here is 9 and this length is 10, what do we think I should do? Here's my x. I don't know this one. But in order to find my third side of a triangle, don't I need to know at least two sides? Isn't that right? Do I know this one or do I not know this one? That's the debate. Am I ever going to give you a question on a quiz you can't solve? No, that would be mean. So there's enough information up here. What do you think, Sabella? What goes there?
10.
10. If this is 10, then that is 10. They match. Why do they match? Because of these key words. Perpendicular bisector. What does bisector mean? It cuts it in half. That means this half matches this half. See how our vocabulary is super important, right? Math's like a foreign language, really. You've got to understand the vocabulary before you have any idea what we're talking about. If this side is a 90, guess what that makes this side of the angle? A 90. Now look what I have. You're thinking, how is this crazy triangle inside of a circle and we're still going to have to do something we learned way long time ago? Well, everything in geometry is sort of cyclical. It all works together. So I know this side is 9, this side is 10, and this side I don't know. How do we find the third side of any triangle if it's a 90-degree triangle? Pythagorean theorem. We're going back, old school, 8th grade style. So a squared plus b squared equals c squared. So let me give you a moment. I would like you to finish that problem. And if you're at home, please type in your answer once you get what x equals. So let me give you a moment. I see some great, perfect answers from those of you at home. Awesome job. Let me just remind you about why we set it up this way. Because Pythagorean theorem is a squared plus b squared equals c squared. C is always the longest side. So in this case, my longest side is the one that I didn't know. So that's why that one stayed the x. The other two I did know. So when I plug them in, I'm going to get 81 plus 100. So that would be 181 equals x squared. How do I go from x squared to x? What do I have to do to both sides? Square root both sides. That's why I said a calculator is handy and acceptable. It's not cheating. And we would get 13 point, if it wants the nearest tenth, we'd get 0.45, but tenth place is right here. It's one decimal. So by the time we round, it'd be 13.5. Final answer. So these are your last two quizzes. Try these problems some more. Switch up the numbers. Make sure you understand them. Come see me if you don't before you take those quizzes. And then I have one last thing to remind you of that we covered last week, and you guys thought, oh, that's easy. And you were right. It was easy. This is what you're starting next week with, so I'm prepping you just a little bit here. And it's that word inscribed, inscribed angles and arcs. This is last week's recording. So if I ask you on your paper in front of you, please draw an inscribed circle and label the vertex. So see if you can, an inscribed angle. So take a moment. Can you draw one on that blank circle? Do you remember what that word means? Seven days is a long time to go between looking at your math notes. Don't let it be 7 days. Okay. Inscribed is where it goes all the way across your circle. That's an inscribed angle. Your vertex would be at the corner. Is that ringing a bell now? Last week we did two things. We did central angles, which were ones in the middle, and we did inscribed angles, which were ones that went all the way across the edge. Are we nodding now, saying, oh yeah, we did do that last week? She's right. Okay, on this picture, I want you guys to highlight the inscribed angle. Out of all the ones that I'm showing you, which one can you call inscribed? Can you highlight it with your pen or your pencil? There's only one up there. Sure. Anthony, can you give me the letters of it? Which one's inscribed? ADB. Great. ADB. Perfect. Let's connect this to last week just a little bit further. Last week we talked about the measure of the arc, correct? Like the arc length, the measure of the arc. Check this out. They all have the same arc length. That's cool. They're not all inscribed angles, but every single one of those has the exact same arc length. We learned that length is different than the degree in this corner. We did learn that last week. So this angle is going to be different than C. It's going to be different than F. The angle is going to be different, but what's not going to be different? The arc length, because they all share that exact same spot where they have their two endpoints on the arc. So kind of cool. They don't always have to match, the arc length and the angle. But here is the relationship. The one that's at the far edge is X. The one that's on the arc is 2X. They had that opposite relationship, right? That doubling relationship. If I give you one, you have to be able to find the other. So we're going to try with numbers in just a minute. We ready to try? Okay, so if I tell you, hey, this itty bitty teeny weeny angle is 25. What is the measure of the arc? Look back at your formula. What do you think? Close. So he said 25x. Not quite how we write it. It's actually 25 times 2. You just double it. So that would be 50. Good job. So if I give you the angle, the inscribed angle, what's the arc angle? Twice as much. 50. It gets doubled. Everybody okay with that? Because here's how you could think of it, right? If I put them with x's like Cody was doing, my inside angle is x. My outside angle is 2x. So if my x is 25, what's 2 times 25? 50. You okay with that? This one would be x. Outside would be 2x. Good job. What if I give it to you backwards? Okay, here you go. Don't say it out loud. I'd like you to try it. If I tell you that your outside angle is 90, please give me your inscribed angle. And if you're at home, please type it in. This one's x. This one's 2x. The one on the outside is twice as big. So Gehrig, what do you think x is? 45. How did you find that? He divided by 2. So when we're going one direction, we're multiplying by 2. When we go the opposite direction, you're dividing by 2. Here's how I think of it. The outside is always the bigger one. So if you're ever confused about, well, which one's which and when do I multiply, when do I divide, your outside number has to be your bigger number. So if you're thinking, oh, I'm going inside, how do you make it a smaller number? Divide would be the answer. You have the small number. How do you go to the bigger outside? Multiply would be the answer. So multiply to get to the outside, divide to get to the inside. Everybody okay with that concept, idea? Okay? Oh, I see a question. I'll wait for just a second. And we could do this all day long. I could tell you the inside's 30. You would say the outside's 60. I could say the outside's 100. You could say the inside's 50. You got to go back and forth, back and forth, back and forth, and be really, really good at it. Okay, so your essential question again for today is, I'd like for those of you at home, you're going to write down the whole sentence and fill in the 2 blanks for me. A line of tangency is blank to the blank of a circle. We might have just highlighted it during the notes today because I had you do that for sure on one of the 2 slides. So thanks guys if you're at home. Have an awesome rest of your day and a great weekend, and I will see you back here next week.